See, here for the simple microscope, we are going to define magnification, but that magnification is angular magnification. Now, this angular magnification is what? That is angle subtended by image at I and angle subtended by object at I, when object and image both are at the least distance of clear vision. Now, what is the meaning of this part? See, suppose you are observing an object. Okay, this is an object. Let's say this is object having height h naught. Okay, and its distance from the eye, that is least distance of clear vision, which is how much? 25 centimeter. At this time, the angle subtended by object at the eye is alpha. Okay. Now, when we will use a convex lens, right? Suppose this is the convex lens which we are using, and its image is formed. Okay. Its image is formed. Let's say this is the height of the image, hi. Now, at this time, the angle subtended by this image on the eye, okay, that is what? Beta. And remember that again over here, this is nothing but least distance of clear vision. Now again I'm repeating statement. What is angular magnification? Angular magnification is the angle subtended by image at eye to the angle subtended by object to eye, when object and image both are at the least distance of clear vision. Is this clear to everyone? भाई आवाज क्लियरली नहीं आई मुझे. Okay. Now here our target is to find the angular magnification for a simple microscope. Okay. Now we know when the object is kept between the focus and optical center of a convex lens, its enlarged image is formed. Okay, that is virtual, erect, and larger than the height of object. Am I right? So from here, can I say beta will be equal to hi upon d, and same way alpha will be h naught upon d. Now if we substitute the value of alpha and beta in equation number 1, what we will get? See, hi upon d, then h naught upon d. D will come in numerator. D cancel. So it is what? Hi upon h naught. So you can see here it is coming equal to linear magnification. This is angular magnification, but here it is coming to us equivalent to linear magnification. Is this clear to everyone? So see here, the linear magnification and angular magnification in this case are equal. So can I say this hi upon h naught is nothing but minus, sorry, that is plus v by u, correct? Yes or no? Angular magnification. Okay. Now over here we will derive the expression for two different situations, right? Now if we use the sign convention, okay, sign convention. Suppose first case I am taking when image is image is formed at the least distance of clear vision. Least distance of clear vision. Okay, in that situation, the V will be equal to D, least distance of clear vision, and U, that will be equal to, sorry, V equals to minus D, and U will be equal to minus U. So ultimately, angular magnification, what we are getting, that is D by U. Is this clear? Now this d by u value, this d by v value, we will derive. Okay. How we will derive? With the help of equation. Okay, length equation. So we know the length equation. The length equation is 1 by v minus 1 upon u equals to 1 upon f. Am I right? Yes or no? Multiply both the sides with v. So it will become 1 minus v by u equals to v by f. And this is again, we can write 1 minus v by f equals to v by u. Again substituting the value, same, v equals to minus d and u equals to minus u. So what we will have, see, 1 plus d by f equals to minus d upon minus u. So ultimately what we are getting, 1 plus d by f equals to d by u. So this is the derivation when the image is formed at the least distance of clear vision and the angular magnification is 1 plus d by f, which is equal to d upon u. This is also known as stressed eyes situation. Stressed eyes, okay, when the eyes are stressed, and eyes will be stressed when the image is formed at the least distance of clear vision. That was the first case. Now second case. In second case, when the image is formed at the infinity, okay, second case, when image is formed at infinity, okay. Now image is formed at infinity, it is also termed as relaxed eyes. So we know the angular magnification, that is d upon u, and as we know, if image is formed at infinity, definitely object is kept at focus. So angular magnification in this case will be d by f. So we will use this formula for the relaxed eyes when the image is formed at infinity. Now here conclusion is that magnification, angular magnification, that is between d by f to 1 plus d by f. D by f to 1 plus d by f. Is this clear to everyone?